Hello everyone, I am Sitara from Gokaraju Rangaraju Institute of Engineering and Technology. Today I am here to explain my BTech final year project which is titled Handwritten Character Recognition to Obtain Editable Text. Coming to abstract, optical character recognition involves identification, classification, and in some applications, correction of optical symbols or patterns present in a digital image. Recognition can be focused on online printed text, offline, and also on handwritten documents. Many applications such as in postal addresses, bank checks, and vehicle number plate verification, etc. require OCR systems to make the processing fast. Segmentation, feature extraction, classification techniques play a vital role to perform character recognition. There are different phases in an OCR to efficiently process the text, such as optical scanning, location segmentation, pre-processing, segmentation, representation, feature extraction, training and recognition, and post-processing. In training phase, random forest, decision tree, MLP and KNN can be used to make system efficient to process huge data. Recognition of handwritten text is an active area of research. Various techniques involved in OCR and their limitations are discussed along with an overview of prediction time of random forest, decision tree, MLP and KNN based approaches. Further, we can extend this topic with image and audio as inputs. Coming to main introduction part, machine learning based optical character recognition OCR scanner will convert images of a typed, handwritten or printed text into machine encoded text. It has been man's ancient dream to develop machines which replicate human functions. One such replication of human functions is reading of documents encompassing different forms of text. Over the last few decades, machine reading has grown from dream to reality through the development of sophisticated and robust optical character recognition systems. The focus of this application is to help various educators, lecturers, and students to make a text document of their handwritten notes. The process of character recognition can be divided into two parts, namely printed and handwritten character recognition. So coming to existing system, this problem is solved by various mobile scanner applications available that take pictures of all the notes and preserves them in PDF format. This solves the storage and preservation problem faced by everyone. However, the problem with the scanned notes is that once they are prepared, one cannot edit them. The task of performing any large modification to these notes would be problematic. Also, in a scanned format, the notes are in handwritten text, which would be difficult for others to understand. So, what is the disadvantage of existing system? So the problem with the scanned notes is that once they are prepared, one cannot edit them. So, coming to proposed system, in this paper we recognize text from uploaded image using OCR. There are different phases in an OCR to efficiently process the text such as optical scanning, location segmentation, pre-processing, segmentation representation, feature extraction, training and recognition, and post-processing. In training phase, random forest, decision tree, MLP, and KNN can be used to make system efficient to process huge data. Recognition of handwritten text is an active area of research. Various techniques involved in OCR and their limitations are discussed along with an overview of prediction time of random forest, decision tree, MLP, and KNN based approaches. So coming to the advantage of this proposed system, to help students, lecturers, staff, instructors maintain notes which can be easily misplaced or lost. So next, coming to software requirements, the functional requirements or the overall description documents include the product perspective and features, operating system and operating environment, graphics requirements, design constraints, and user documentation. The appropriation of requirements and implementation constraints gives the general overview of the project in regards to what the areas of strength and deficit are and how to tackle them. So in this we use Python IDLE 3.7 or Anaconda 3.7 or Jupyter, Google Colab. Coming to hardware requirements, minimum hardware requirements are very dependent on the particular software being developed by a given Enthought Python Canopy VS Code user. Applications that need to store large arrays or objects in, uh, in code user in memory will require more RAM, whereas applications that need to perform numerous calculations or tasks more quickly will require a faster processor. Here we use operating system like Windows Linux, processor minimum Intel i3, RAM minimum 4 GB, hard disk minimum 250 GB. So this is the system architecture of our project, which includes image dataset, pre-processing, choosing of image, character segmentation, clustering, annotation of clusters, database creation for every document image, character segmentation, recognition using the database, and ASCII text. Here, for annotation of clusters and database creation, users interference is required. This is the data flow diagram. Here, first the system will check whether the user is authorized or unauthorized. If the user is authorized, then it follows all the steps like data exploration, data pre-processing, feature extraction, model generation, build random forest, decision tree, MLP and KNN model, accuracy graph, upload text image, recognize text using OCR, predict time, and at last the process will end. So coming to the results, to open the application, first we need to run some commands in the Anaconda prompt. After running the commands, a link will be displayed over here. Clicking on that link, it will be redirected to the required application. So this is the application which we use. In this, we need to upload an image over here and the required output will be shown here in the recognized text block, and also prediction time is shown. So these are all the examples. These are all the screenshots which we have obtained as a result. This is one more example. So we can see that we can also perform digits calculation by writing in this block, and by clicking on the answer button, we'll get the required output. And at last, to conclude, machine learning based optical character recognition, also known as OCR, scanner is a combination of a word processor and OCR processor that is used to convert any type of paper-based document into a computerized document without altering the structure of the document. The user is supposed to provide an image or scanned document of the data that is uh, that is needed to be converted into computerized text to the system. The system will take the input and extract the text from that input. Then it will maintain the font or styling of the text if it is available. Else, if the input is handwritten, then the system will maintain the structure of the document. This system will result in the efficient management of documents, and any organization can step towards a paperless approach using this software. As extension work, we are performing two operations such as image and audio inputs for hand character recognition. Thank you.